Ready?
I am. This week is the second anniversary of our YouTube channel, the Periodic Table of Videos, and we're all very excited. It's traditional that when you have an anniversary, you give a present to your partner, in this case to our viewers, and the traditional present for the second anniversary is cotton. So we have a sample of cotton and some things to say about cotton to give you to celebrate our anniversary. Okay, so what we're doing today is Neil has made us some gun cotton, which is ordinary cotton wool that you treat with a mixture of nitric acid and sulfuric acid, and hopefully we're going to get something that's going to go up in flames pretty well. Have a look at my tie, and you can see on here are some rings with 5 carbons and an oxygen, and these rings represent glucose. The unusual thing about glucose is that the rings of glucose can join together. If you join 2 rings together, you get sugar. These rings can join together to make very long chains, and depending how they join together, they can make either cellulose or starch. What happens in cellulose is that you have these rings that are joined together, and these chains in the plant, like in cotton, line up together, and cotton, the fibers of cotton, are made out of cellulose. The reason why chemists get excited about cellulose is because these rings have joined to the carbon atoms OH groups, and the OH groups react quite easily. So you can take something else and react it onto the various chains. And one of the things that chemists like to react with it is nitric acid, which puts on nitro groups. Okay, so Neil's going to come in with our match on a stick and set fire to the cotton wool. Let's see what happens. What the nitro groups do is to make the cellulose burn really well, so-called gun cotton. Whoa! That was pretty impressive. Whoa! Whoa! So I think that was quite a vigorous reaction. I don't know if you've ever thought about this, but if you have one of these really big guns, like they used to have on battleships, you need an explosive to push the shell up the gun barrel and out. But the shell is really heavy. So if you have an explosive like dynamite that goes bang very quickly, the shell doesn't have time to move and you'll just blow up the whole gun. And so you'll destroy your ship, but you won't shoot at the enemy. But gun cotton burns nice and steadily, so the pressure builds up and it accelerates the shell out of the gun. The other thing is that when this nitrocellulose was first discovered in the 19th century, people got really very excited because they could dissolve the nitrocellulose in a variety of organic solvents. You can't dissolve up cotton, not easily anyway. And they discovered they had this material, nitrocellulose, which they could dissolve up, and then they could evaporate the solvent and make all sorts of objects. And the first thing they discovered they could make was something that looked very like ivory. This is ivory from an elephant. I should say straight away that I didn't buy this. I got this a long time ago, and although one shouldn't have ivory, it seems unfair to the elephant to throw this away. But you can make artificial ivory, or what looks like ivory. They used to make billiard balls for pool and for billiards out of nitrocellulose, the same material that you use for propelling shells in guns. So fortunately it's stable enough that when you have a good shot and the balls hit each other, they don't go bang. But they must have burnt quite fiercely if the house caught fire.
Are billiard balls still made out of nitrocellulose?
No, billiard balls are now made out of plastic.